My name's Bridget Corcoran. I'm the in vitro manager here at Certis Oncology. I specialize in PDX tissue culture techniques, mostly 96 well, 384 well plate assays, including MSD, flow cytometry, IHC, PCR, Western blotting, and ELISAs. We have a really great, fabulous team here at Certis.
Our PDX Drive cultures, we grow them serum free. That is the purpose of it, is to maintain that sort of the stem cell population, the cancer stem cell population, or the undifferentiated portion. It just maintains the heterogeneity of our cultures. So once you start working with serum, whether it be cell lines or primary patient or PDX derived in serum, you lose that heterogeneity and you lose that expression and closeness to the original tumor. Custom, it just requires a lot of thought and a lot of sort of scientific intellect, because not everything is just transferable from a cell line to a PDX derived culture. It could be completely different. It could be apples and oranges. We have 3 QC parameters, but one of them is for a fully developed line and the other one's sort of most basic. So number 1, mycoplasma testing. Our culture is mycoplasma free. That's the basics of any in vitro. Everyone has to do it. Our other QC step is human versus mouse content. So anytime we generate a culture from a PDX model, we run flow cytometry on it to determine the percent of human cells versus the percent of mouse cells. We have a cutoff of 80%. That's our low cutoff. You have to be at least 80% human. Anything below that, we attempt to mouse deplete. But typically, most of our cultures are either 98, 99 and above percent human, or they're just not, and we have to mouse deplete. So those are our main QC. Another thing that we do after we've basically taken those steps, we've frozen them, we've revived them, we then send them out for RNA-seq and whole exome sequencing. So that way we can see how closely our PDX cell line matches our actual PDX tumor, just with regard to expression mutation profile. And then, of course, the last step, which would be the fully developed everything, would be, number 1, does it form a tumor in mice? So we implant it into animals. We see if it forms a tumor. What are the growth kinetics of that? Does that mimic the PDX? Does that mimic standard of care or whatever we treated it with?
I'm really excited that we have the most clinically relevant models on the market and that we are exploring some of the most deepest sides of oncology with those models, and I'm really excited to see the positive discoveries that could come out of the work that we do.